Hello everyone. Today we are again looking at congruent triangles, and we're setting up several proofs here to show that these triangles are congruent, but then we're pushing it one step farther because you'll notice that we are not asking you to prove that the triangles are congruent, but to show that some other part of the triangles are congruent. But if we're going to show that, we have to first show the triangles are congruent before we can talk about any other parts. So what we're looking at doing today is, for the first part, working to show the triangles are congruent. So if you look at example 1 just as an outline of where we're headed, you'll notice that here on line 3 it says this triangle is congruent with that triangle. And traditionally we have stopped there. We would determine the pattern, whether it was side, 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 or side, angle, side, or whatever the case may be. So up to this point, the idea of doing these proofs is the same kind of work as what we've been looking at in the past, but now we're going one step farther. We're saying if those triangles are congruent, what can we say about some other pair of corresponding parts? And that's what this little introductory paragraph is talking about. It says, by definition, congruent triangles have congruent corresponding parts. That means if your triangles are congruent, what do we know about the other parts? Well, those other corresponding parts must also be congruent. So, if you can prove that two triangles are congruent by using only 3 pairs of corresponding parts, remember you always need 3 pairs of corresponding parts to be congruent, then you know that the other 3 corresponding parts that you didn't use to prove the triangles are congruent must be congruent as well by the definition of congruent triangles. Let's work that through and talk about this. So again, we have some given information, and just to get us started here, that has already been provided on line 1. Now if we're naming it, you have to mark it, right? So I'm always trying to emphasize, mark the diagram, because you need the markings to determine what the pattern is on showing the triangles are congruent. So here we have segment AB, that is congruent with segment DE. Here we have angle ABC is congruent with angle DEC. So all of that is the given information. There it is on line 1. And we go back to the diagram and we say, is there anything else we know about this? And we say, hey, we have some vertical angles right here on either side of angle C. Now, on either side of point C. We cannot just call it angle C because there are too many other angles that share the common vertex. So notice, we can't just say angle C is congruent with angle C. We have to use the 3-letter combination. So I just want to make a note of that. Say, note, it's wrong to say angle C congruent with angle C, right? So we don't want to do that. You can't just use angle C because there are too many angles that share vertex C. So that would be the wrong way to do it. This is the right way to do it. And those are vertical angles, right? So if angles are vertical angles, then they are congruent. Then they are congruent. Now you may remember from a few days back when we were doing these 2-column proofs, I always counted the number of congruent parts to see if I had 3. There's our first pair, there's our second pair, there's our third pair. Once you get to 3, that's when you know you are done with the proof, essentially, because our very next line was to show that the triangles are congruent. Of course, in today's work, we're going a little bit farther than that, but you always have to have those 3 pairs of parts. So notice we didn't use all 6 pairs of parts. We didn't use all the sides and all the angles. We just used some sides and some angles. So we can now say that the triangles are congruent by reason of, we look at our markings. I see 2 angles that are marked. I see a side that is marked. The side is not between the 2 angles. That would be an angle side angle pattern. But no, this side is not between, so it's an angle side pattern. And so we know now that the triangles are congruent. So think about this for a moment. If the triangles are congruent, that means they are exactly the same. They're exactly the same size and shape. So if they are exactly the same, then what do we conclude about some of these other parts that we didn't even use in the proof up to this point? Right, when we're trying to show that the triangles are congruent, we were using some sides and some angles. We didn't use all the sides. We didn't use all the angles. It was some combination of that. So that means there were other sides and other angles that we didn't use in the proof. But if the triangles are exactly identical, then what could we say about these corresponding parts? Well, they have to be the same, because they're on triangles that are the same, aren't they? So here's our if-then statement. This is the new piece. This is what we're learning today. So here's the if-then statement. Remember, the if always describes what came before. What came before? We have congruent triangles. So if congruent triangles, or you could say if triangles are congruent, then corresponding parts are congruent. So if triangles are congruent, or if congruent triangles, then the corresponding parts are congruent. So notice we're not saying corresponding sides, because in other proofs we might be talking about corresponding angles. So we just use the general word of parts. Corresponding parts are congruent. That is going to be true because they are sitting on the triangles, which are identical. So that's what we're looking at doing today. We're going to start off by showing that triangles are congruent, and then we have one additional line of the proof where we're looking at specific parts. These corresponding parts will then also be congruent. So this is sort of the magic phrase. This is what we're going to use, and this is what we're going to keep coming back to on each of the proofs today. That's exactly how we'll finish them up. So there's this kind of structure. You find three parts to show that the triangles are congruent. Then we look at a fourth pair of parts and we say, hey, if the triangles are congruent, these corresponding parts are congruent as well. So let's take a look at another example. Here's example 2. Now, I see lots of possible triangles. There's this sort of upper left triangle. There's this lower left triangle. There's this big triangle on the left, and then, of course, matching on the other side as well. 6 different triangles, and then of course there's a triangle and there's a triangle. What triangles are we talking about? I don't even know what triangles we're trying to emphasize. So when we are marking up our diagram, we want to keep track of where these markings are falling so we know which triangles we're trying to show as congruent. You'll also notice that there are no statements or reasons numbered, so we'll make this proof as long as it needs to be. Starting off with segment BD is congruent with segment CD. And then angle BDA is congruent with angle CDA. So those are the only markings we have. So can you identify the triangles we're trying to prove by the placement of the markings? So notice that if we were trying to show that this triangle on the bottom left was congruent with this triangle on the bottom right, that would not be very good because we only have one set of tick marks and nothing else to go on. Notice that instead, if we look at sort of the top left triangle and the top right triangle, notice now we have not only sides that are marked, but we have angles that are marked as well. So these two triangles are what we are working with. So I'm just going to outline them so that they stand out a little bit better in the diagram. So we're trying to show that this triangle ABD is congruent with this triangle ACD. We knew to pick those two triangles because that's where the markings fell. We have a pair of sides that are marked and a pair of angles that are marked as well. They're marked, so we need to name them. Line 1, segment BD is congruent with segment CD, as well as angle BDA is congruent with angle CDA. Should we put that on one line or two lines? It doesn't really matter. It's up to you. I'll just put it on one line. Now notice that what we have been given so far is one pair of corresponding parts congruent, two pairs of corresponding parts congruent. How many do we need? We have to have three, don't we? So that tells us what to look for. We need to find a third pair of congruent parts. So go back to the diagram. Do you see anything we can add? Here's that shared side. We're allowed to put tick marks on that. We've marked it, so we must name it. That's segment AD. So segment AD is congruent with segment AD. That's our reflexive property of congruency. And now notice we have three pairs of congruent parts. So we don't have to look for any more parts. We're now at the point where we can identify that the triangles are congruent. So the triangle on the left is triangle ABD, and that is congruent with the triangle on the right, ACD. And what's the pattern of the markings? Looking at one of those triangles, you can see we have two sides that are marked, one angle, the angles between the two sides, we have a side, angle, side pattern. And again, it used to be that we would just stop our proof here because that's what they had been asking us to prove, but now we're going one step farther. Notice what they're wanting us to show is that angle BAD, that's this angle right up here, is congruent with angle CAD. How do we know those angles are congruent? Because they are sitting on two triangles that are congruent, that are identical to each other. So as you remember, the last line is the thing they're asking us to prove. Angle BAD is congruent with angle CAD. And what's our reason? It's this magical phrase. This is going to keep coming back for today. This is the new piece of information we're learning. The if is describing what came before. We figured out that we have congruent triangles. So if congruent triangles, then corresponding parts are congruent. So again, notice we're not saying corresponding angles are congruent, we're just keeping it the general corresponding parts, because depending on the example, depending on the proof, it could be sides, it could be angles, so we just call it corresponding parts. So that's essentially what we're trying to do today. So examples 1 and 2 here illustrate how we're trying to show the triangles are congruent and then finish off with that final part. So what we're doing with these next two examples is we're making it a bit more complex in terms of trying to show the triangles are congruent before we can then show the corresponding parts on those triangles are congruent. These proofs will be a little bit longer because they're giving us some given information that has congruent parts, but other given information is talking about something else, and so we'll have to figure out what these other pieces of information are doing for us here. Alright, so the purpose of example 3 and 4 is to kind of see what other variations we could encounter with what other kinds of given information are provided. As always, the real challenge here with proofs is, can you do it? Because it requires a lot of thinking, a lot of connecting the dots, being able to put these things in the correct pattern and sequence. And even though I can demonstrate it here, it really isn't going to be enough just to sit back and watch. You really need to try these yourselves. So, what I really recommend is that after we go through this proof and we finish up the notes, before you try any practice problems or any homework, you should cover up this page and try it again. In other words, you're not doing it from memory, but you're trying to see, can you put together the pieces that we just talked about in these examples. Alright, so let's go ahead and get this started. Statement number 1. I'm going to group these given pieces of information because here this first piece is talking about congruent parts, and then the second and the third pair has to do with perpendicular. So those are two different ideas. So I want to split those up. So statement number one, here I have segment AD is congruent with segment BC. Again, we could put all of this on one line, and that's totally fine, but I just want to split them up. Here is segment AD perpendicular with segment DC, segment BC perpendicular with segment DC, also given. So, like I said, we could have just put that on one line, but we need to mark that up so we can keep track of what we know on our diagram. Segment AD congruent with segment BC. There it is. And then we're told that segment AD is perpendicular to DC. Well, we know that if there's perpendicular lines, they're going to form a right angle. So if I am marking a right angle, then I need to name it here. All right, they are forming a right angle. So on line 3, even though we're starting off with the perpendicular lines, the way we mark the diagram is with the right angle, because that's what the perpendicular lines form. So we need to identify this by name. What angle is this? Not angle D, it's angle ADC, because you need a 3-letter combination. So angle ADC is a right angle. Now that came just from the first pair of perpendicular lines. We have another pair of perpendicular lines. So we're told that segment BC is perpendicular with DC. So again, we mark that with a right angle, and if I've marked it, then I need to name it. So I'm sharing the same line 3 and saying, in addition to angle ADC, we also have angle BCD. So angle BCD is a right angle. We could have combined this into just one statement and just calling it angle ADC and angle BCD are right angles. We could have done that as well. But what's our reasoning? Well, we know that right angles are formed from perpendicular lines. So if perpendicular lines, right, the if part describes what came before, then is what we have right now. Then there are right angles, or we could say then they form right angles. Now, as we're marking this up, we're also trying to keep in mind what triangles are we going to have to show to be congruent. Because we have something that looks like a rectangle with the diagonals inside, we have lots of triangles in here. So can you identify what triangle we might be working with? Look at where we've marked up the items. We've marked up the sides, the left side and the right side. So we know we have to have a triangle that touches these segments. And then we marked up this angle on the left at D and this angle on the right at C. So we need a triangle that's going to be touching this side AD as well as including this large angle at D. So those are the two sides that we know. So that means the third side of our triangle must be like this. In other words, we're going to have overlapping triangles. So it might be helpful to redraw them separate. There's A at the top, there's D at the bottom, there's C on the right-hand side. And again, we have this tick mark on segment AD and this right angle at D. That means the other triangle is going from B to C, and then again sharing along that bottom edge, so that we have angle C in there, and then there's our third side of the triangle. So that could also be pulled apart and separated and redrawn. So B is at the top, C is at the bottom, D is on the left-hand side. The tick mark belongs on segment BC, and the right angle belongs here at C. Those are the two angles, the two triangles that we have to show as congruent. So recall that if we want to show triangles are congruent, we have to have 3 pairs of congruent parts, and we only have 1 so far. We don't have any other congruent symbol yet. So we need to look for something that is congruent. Alright, what about these right angles? If these two angles are right angles, are they congruent? Absolutely. So now we say angle ADC is congruent with angle BCD. And the reasoning here is, if two angles are right angles, then they are congruent. Remember, the if part describes what came before, and what came before on line 3 is that we have two angles that are right angles. So if two angles are right angles, comma, then what do we see? They are congruent. Here's the rest of that line. Then they are congruent. So now we are up to 2 pairs of congruent parts, which means we're not done yet. We still have to find a third pair. Do you see anything in this diagram that we could add to the markings? Do we have any vertical angles? It looks like we have vertical angles here on the original diagram, but when we pulled the two triangles apart, that point E doesn't exist, so we do not have vertical angles on these two triangles. Instead, notice that the bottom segment from D to C has the exact same name. If it has the exact same name, they must be congruent to each other. That's where they are overlapping completely from endpoint to endpoint. That's your reflexive property right there. So we've marked it, we have to then name it. So this is segment DC is congruent with segment DC, and that is our reflexive property of congruency. And so now we have 3 pairs of congruent parts. So now we can say the triangles are congruent. So triangle on the left, triangle ADC, is congruent with the triangle on the right, triangle BCD. And the reason is we have a right angle. So what do you think? Is it RHL? There's the hypotenuse, but there's no markings on the hypotenuse, so it is not an RHL pattern. No, it's a side angle side pattern. So we did that in 6 steps so far. We're not quite done. Again, we could have combined these two into a single line to make one given statement, so we could have made it a little bit longer. But this is the idea. First, show the triangles are congruent, and I've been focusing exclusively just on getting that done, because now if the triangles are congruent, now we can go back and say, well, what do we know about some of these other parts? What do we know about segment AC and BD? There's no markings on it, no tick marks, but are they going to be congruent? Now they will be, because they exist on congruent triangles. So here's the last line. We have proven that segment AC is congruent with segment BD because if congruent triangles, then corresponding parts are congruent. If congruent triangles, then corresponding parts are congruent. So we ended up doing that in 7 steps altogether. We could have pushed it down to 6, but that would have been as short as it could have been. Here's example 4. You can see with the given information that there are 2 sets of ideas here. This first pair is talking about parallel lines, and this second set is also talking about parallel lines. So they really go together. They're not 2 different ideas. It's 2 ideas about parallel lines. So I'll put them both on the same line number 1. Segment AB is parallel with segment CD, and segment AD is parallel with segment CB. So if it's named, it must be marked, and it already is, so you can see with the placement of the arrows. Now remember, the arrows are not talking about congruent parts. So if we're going to show the triangles are congruent, we have to have 3 pairs of congruent parts, and right now we have 0 pairs of congruent parts. So, do you recall what I said about what the parallel lines give us? If we have parallel lines cut by a transversal, then that means we have certain pairs of congruent angles. So we have to remember what they are. What's the name of that? Are those corresponding angles? Are those alternate interior angles? Are those alternate exterior angles? Or are those consecutive interior angles? They have to be alternate because they're on alternate sides of the transversal. One's above the transversal and one's below the transversal. And they're inside the parallel lines, so they have to be interior. Alternate interior is their name. So if we've marked that angle, we need to name it. And we've learned that if parallel lines, then these alternate interior angles will be congruent. So again, don't just call it angle B. You have to use a 3-letter combination. So angle ABD is congruent with angle CDB. So that angle pair came from this first pair of parallel lines. And now we can have a second angle pair that comes from the second pair of parallel lines. So this is segment AD on the left, parallel with segment CD on the right. So if these are the parallel lines, again, this is still our transversal, then we want an angle pair that is touching those parallel lines, and we see that here and here. So I'm going to use the same line number 2 because we have the same reason. So this is angle ADB is congruent with angle CBD. And again, we know those are congruent angles because of the parallel lines on the left and the right side. So our if-then statement is, if parallel lines, then alternate interior angles are congruent. Now you can see here on line 2 we got 2 pairs of congruent parts. So we went from a state of having 0 pairs of congruent parts to all of a sudden jumping up to having 2. Again, we always have to have 3. So go back to the diagram and see if there's anything else that you can add. There's our shared side, so a tick mark on segment DB. So statement number 3, segment DB is congruent with itself. And that's our reflexive POC. And now that we have 3 pairs of congruent parts, now we can say the triangles are congruent. So let's see, triangle, I'll go along the top here this way. I'll go triangle ABD is congruent with triangle CDB. We look at the pattern in the markings to identify why the triangles are congruent. I see 2 angles that are marked and one side that's marked. The side is between the 2 angles, so this is an angle side angle pattern. Now that the triangles are congruent, we can say, what about these other parts? Now you'll notice that instead of just being 1 pair of parts that we had to prove, like in the previous example, there are in fact 2 pairs. Well, it's all the same reason, because if the triangles are identical, then that means these corresponding parts must be congruent as well. So what can we say about this top side and this bottom side? Will they be congruent? Yes, they will, because they are on congruent triangles. What about this left side and this right side? Are they congruent? Yes, they are. They are congruent. So let me jot that down, and then I have a final comment here. share the same line as it's the same reason, which is if congruent triangles, then corresponding parts are congruent. And a little bit off the screen, let me adjust the camera. So there was the final proof statement listed on line 5, and here's reason number 5. If congruent triangles, then corresponding parts are congruent. Alright, first, be very careful. Do not just assume that because you have sides that are parallel that automatically makes them congruent. That is not the case. For example, here I have a segment, here I have another segment, and I'm going to say that segment AB is parallel with segment CD. Alright, if I tell you these are parallel, does that also make them congruent? I mean, does that make them the same length? No, this one is clearly bigger. Alright, so the note here is just because you have parallel lines, that doesn't mean the same thing as congruent segments. So in this proof here, it just so happened that our parallel sides were also congruent because we proved it to be the case. But don't just assume that parallel lines also make them the same length. No, no, no. Here's an example of parallel lines that are not the same length, and we see that a lot in a trapezoid, right? A trapezoid has parallel sides, but they're clearly not the same length. And then the second point I'm making, again, these were challenging proofs, but I want you to practice them. In other words, cover up what we just did, pretend it's not there. Get a blank piece of lined paper, redraw the diagram, start off with the given information. Can you work your way through it yourself? Because that's the real trick. That's the real challenge. Can you do the proof yourself? Not just from having memorized it, but can you put this page away for 5 minutes and then come back to it and reason your way through it the way we just did it here in our notes? That's the challenge, of course, because every proof is different, and you can go on to the homework and do those, and those diagrams will be different than these, so it's hard to necessarily carry over exactly all of the variations on the proofs that we might encounter or experience. So that's why I'm saying it's so important that with the notes on these proofs, you take the time to try going through them again yourself by covering up what we've done, and then reveal what you have. Compare it with the notes that we have and see if you were able to hit every line. And if you're missing something, then that's something you star and flag and kind of go back and have to study, and you just fill that in with what it was that we had talked about here.